Dear students, welcome back. So we have been discussing about the properties of the Fourier transform. Now let us see the next property, that is the differentiation in frequency domain property. That is, if the Fourier transform of x of t is equal to x of omega, then the Fourier transform of t into x of t is equal to j into d by d omega of x of omega. Once again, I will repeat, the Fourier transform of x of t is equal to x of omega. Then the Fourier transform of t x of t is equal to j d by d omega of x of omega. This is known as the differentiation in frequency domain. So that is because we can see here on the right hand side d by d omega of x of omega. Let us see the proof of this property. So we all know x of omega, that is a Fourier transform of x of t, is defined as integral minus infinity to infinity x of t e power minus j omega t dt. Now let us differentiate both sides with respect to omega. So in the left hand side, d by d omega of x of omega is equal to, in the right hand side, d by d omega of the given function. Now we can differentiate this right hand side. Here we are differentiating it with respect to omega. That is why there is only one function that contains omega, that is e power minus j omega t. So here e power minus j omega t il മാത്രമാണ് omega ഉള്ളത്. So ആ ഒരു ടേമിനെ മാത്രം നമ്മൾ differentiate ചെയ്താൽ മതി. So we are simply differentiating e power minus j omega t, d by d omega of e power minus j omega t. ബാക്കിയുള്ള ടേംസ് എല്ലാം അതേപടി നമ്മൾ keep ചെയ്യുക. That is integral minus infinity to infinity x of t d by d omega of e power minus j omega t dt. So what is d by d omega of e power minus j omega t? So we all know d by d omega of e power minus j omega t will be equal to what? E raised to x ന്റെ differentiation എന്ന് പറയുമ്പോൾ derivative e raised to x തന്നെയാണ്. That is, this will be e raised to minus j omega t divided by, that is into what? Into minus j into t. Okay, e raised to minus j omega t into minus jt. Okay, so here we are differentiating it with respect to omega. So the minus jt is here, e raised to minus j omega t is here. So this minus j is taken outside. What is the remaining term? That is equal to t into x of t. This minus j goes to the outside. So outside of this integral. So minus j integral t into x of t e raised to minus j omega t dt will be equal to minus j into Fourier transform of what? Tx of t. This is nothing but minus j into, we can see the remaining term is in fact the Fourier transform of t into x of t. So we put it as a Fourier minus j into Fourier transform of t into x of t. So left hand side we can see d by d omega of x of omega. Right hand side minus j Fourier transform of t into x of t. Okay. Now let us make a rearrangement here. That means this we can take this Fourier transform of t into x of t, and this minus j goes to the left hand side. So that will be equal to what? That goes to the denominator. Then it will be 1 by minus j d by d omega of x of omega. So this minus j, or the minus 1 goes to numerator. Minus 1 goes to numerator. Minus 1 is nothing but what? J square. J is root of minus 1 and j square is equal to minus 1. We all know in the complex numbers, j is denoted as root of -1. Okay, so j square is equal to -1. So the numerator there is a j square divided by j. So what remains there is j. Okay, j into d by d omega of x of omega. So that is the Fourier transform of t into x of t. That is j into d by d omega of x of omega. This is the differentiation in frequency domain property. Now let us see the next property, that is the time integration property. So according to the time integration property, if the Fourier transform of x of t is x of omega, then integral minus infinity to t x of tau d tau, its Fourier transform will be equal to 1 by j omega x of j omega if the initial condition x of 0 is equal to 0. Okay, this is 1 by j omega x of j omega. So the proof is like this. We can prove it. X of t is equal to 1 by 2 pi integral x of omega e raised to j omega t d omega. That is the equation for inverse Fourier transform. Now replacing t by a dummy variable here tau, then it will be t by tau. Okay, so that becomes x of tau 1 by 2 pi integral x of omega e raised to j omega tau d omega. T ക്ക് പകരം നമ്മൾ tau ആണ് യൂസ് ചെയ്യുന്നത്. We are introducing a dummy variable here. So then we are integrating both sides over minus infinity to t. Okay, so we are integrating from minus infinity to t. So the left side integral minus infinity to t x of tau d tau, right side integral minus infinity to t, the remaining function 1 by 2 pi integral minus infinity to infinity x of omega e raised to j omega tau d omega, then d tau. Okay, so here we are integrating it with respect to tau. Now we can interchange the order of integration. Here in the right hand side we can interchange the order of integration. So 1 by 2 pi goes outside, then integral minus infinity to infinity x of omega comes there. Then we are taking the integral this one, that is minus infinity to t integral minus infinity to t e raised to j omega t dt d tau d omega. Okay, so the order has been changed. Now here we can consider this integration which is given in this brackets, inside the bracket, that is integral minus infinity to t e raised to j omega t. So what is it? So when we are integrating e raised to j omega tau, that will be e raised to j omega tau divided by j omega. So the limit is from minus infinity to t. So we are applying the upper limit, then e raised to j omega t will be the upper limit. Then we are applying the lower limit, e raised to j omega minus infinity, that is e raised to minus infinity, which will become 0. So the denominator is here j omega, that goes along with this x of omega. So x of omega by j omega. So we are applying the limits here, that then we will get e raised to j omega t minus 0, which is equal to e raised to j omega t. So that has been reduced to what? 1 by 2 pi integral minus infinity to infinity x of omega by j omega e raised to j omega t d omega. Okay, so if you look at the right hand side, we can see this is nothing but, what is it? This is nothing but the inverse Fourier transform of x of omega by j omega. So this is nothing but as per the definition of the inverse Fourier transform, 1 by 2 pi integral x of omega by j omega e raised to j omega t d omega will be the inverse Fourier transform of what? X of omega by j omega. Okay, so now we are taking the Fourier transform on both sides. So in the left hand side, Fourier transform of integral minus infinity to t x of tau d tau, and in the right hand side we are taking the Fourier transform of inverse Fourier transform of x of omega j omega. So you can see we are taking here the Fourier transform of the inverse Fourier transform. So that is nothing but x of omega by j omega. Okay, inverse Fourier transform എടുക്കുകയാണ്. So that is Fourier transform and inverse Fourier transform, that will be get cancelled. So what here, x of omega by j omega. So we can say finally we are getting the Fourier transform of integral x of tau d tau is x of omega by j omega. So 1 by j omega x of j omega. So this is the integration in time domain property. Thank you.